In this video, we are going to continue with section 2.2. We're going to start with exercise 1 on page 33 of your class notes booklet. Let's go ahead and do number 33 together. The functions are written in point-slope form. State the point on the graph, x naught, y naught, and the slope, m. So if you remember from the page before, the formula is either y or f of x, and it's y naught plus m times x minus x naught. So I look here and I see that my y naught must be -3. My x, you have to be very careful with the x because the x naught is actually, believe it or not, -2. Because, let me just do a sense here. If I rewrite this with that minus in the formula, so the minus is for the formula, so therefore it has to be -2 to turn it into a +2. And the m is 7. So you could write it like this, or you could write it as in what we call an ordered pair. -2, -3. The x always comes first in an ordered pair. This is the x naught, and this is the y naught. That is the answer. If you want to try part B, you can pause it and come back. But here is the answer. Let's still do it together. Let's start with the m this time. What is the m? There's nothing in front of the parentheses, so there's a 1 there. So there's an imaginary 1. The m is -1. And they're just using t instead of x naught and y naught here. You can call it t naught if you want, but since they said x naught, I'll go ahead and call it x naught. The x naught is not -5, it's just 5. The minus is for the formula, and so the x naught is 5. And the y naught, there is no other term that we're adding. So it turns out to be 0 because there's no variable there at all. This one is a 1 because you can't have 0 times something and it to be a value. That would be 0 if that was the case. So you could write it like this, or you can write it as 5, 0. The next exercise is on the next page. Go ahead and try that one. Are you ready for this one? Okay, let's try exercise 2. A company's profit after T months of operation is given by the following formula. It says P of T is equal to 1,000 plus 500 parentheses T minus 4. What is the practical meaning of the 4 and the 1,000? So the 4 and the 1,000 looks like the x naught, y naught in our formula. So that would be the 4, and this would be the 1,000. What does the 4 and the 1,000 mean? What's the practical meaning? Well, if you see x is like the t, usually, because we know that the input is t here, is in months. And so therefore this one is the y, which is the profit in dollars. So this tells us that, I'll start with the 1,000. The profit is $1,000 after 4 months. That's the answer of what the 4 and the 1,000 means. Okay. Let's rewrite this in slope-inner form and give the practical meaning to the m and the b. We'll see how that differs. So if you remember, slope-intercept form, this is called slope-point form. Slope-intercept form is the y equals mx plus b, or the book likes to put the b first, and they use a t, which is perfect here because we are as well. So that is the slope-intercept form. That's the formula. So all we got to do with ours is get rid of the parentheses and combine like terms. So let's go ahead and do that. So P of T is equal to 1,000, and I'm just going to go ahead and get rid of the parentheses by using the distributive law there and get 500T minus 2,000. I'm going to combine like terms, and so here it is. That rewrite the function in slope-intercept form, that is the answer. So give the practical meaning of the m and the b. So the m we know is 500, which usually is the change of y over the change of x, the rate of change, which the y again is the profit. So that would be like the change of p, in our case, over the change of t, the profit per months. So it looks like the profit is increasing by $500 per month. That's what the M means. What about the B? The B we know, that's weird, is negative 1,000. That is the initial amount when t is 0. We're at a negative 1,000, and that would be in dollars because it's an amount, and the t would be 0, the months would be 0. So what does that mean? It means initially the company was in debt for $1,000. It was in the hole, right? It was negative 1,000. It started at negative $1,000. Maybe it borrowed $1,000 to get started, or how much it spent to get started. Who knows? Okay, so now let's try exercise 3. So the line, we know a linear function means line. So line means linear. So that I'm just going to write that there. So we're going to use the same formula. Containing 2 points, negative 2, 1, and 2, 9, write a formula. So I'm going to use the same formula that we've just been using. But what I'm going to do here is I need to find, I got a point. In fact, I have more than enough points. I have either one. You can use either one. I'll go ahead and use that one for my x naught, y naught. But I need to find the slope. So how I'm going to find the slope is I'm going to do the formula, or if you'd rather, f of b minus f of a, all over b minus a. But this would be 9 minus 1 all over 2, right? Because this is going to be my x2, y2. This is actually my x1, y1 maybe. So it would be 9 minus 1, new minus old, new minus for the formula. There it is again. So it looks like it's 8 over 4, which is 2. I know that's coming into that one, so I'll put a line right there to the one before. So we won't confuse that. So now I have all my bits. I can plug these in here. We know the y naught is 1. We know the m is 2. And we know the x naught is negative 2. So again, a minus for the formula and then a negative 2. So it turns out to be plus 2. 1 plus 2, x plus 2. You can leave the answer like that, but I'm going to go ahead and erase this and talk about this a little bit more. So I'm going to erase exercise 2 there. It doesn't really matter. I'm going to show you an or here. Again, you don't need to do this, but it doesn't really matter which point that you use. You could have used y equals this point. Let's try it. The y naught is 9. You think, how is this possibly the same? The slope is still 2, x minus 2. That works as well. These two are the same equations, and you can see this if you go ahead and put this, simplify this by getting rid of the parentheses and combining like terms. You would get 2x plus 5. Did we get 2x plus 5 on our first one? Let's try it. 2x plus 4. Oh, you do. It's still 2x plus 5, no matter which point you use. Interesting. So you go ahead and try part B. Part B is the same thing. It's just instead of the new ordered pair, it's putting it in the function notation. But this is still the x naught. I can start you off with that. And this is the y naught, or x1, y1, whichever one you would choose. And then this would be the second point. So it's the same as part A. So you're going to use these 2 points. Pause and come back for the solution. First, going to find my slope. I'm going to call this x1, y1. I'm going to call this x2, y2. And so it's the new minus the old, the new minus the old. And you can cancel, divide the top and bottom by 10 to make those smaller. You don't have to, but you can. Then I'm going to plug it into the formula. And again, x naught, y naught goes through any point on the graph, so it really doesn't matter which one you use. I'll go ahead and use the first one here, but if you use the second one, it would work as well. So my y naught is 70, my m is -6/5, and my x naught is 20. You can leave that as the answer, or you can distribute the 6/5, combine like terms, and put it in what we call slope-intercept form. Remember, this one is in slope point form, and the second one is in slope-intercept form. If you went and used this point, you might get different slope point form, but you should get the same slope-intercept form. You can try that for more practice. Same thing here. Get a lot of practice with this. Same thing, 2 points, write a formula. See if you can do it. Pause and come back. I'm just going to write down the solution this time. So here's the solution. You should have gotten y equals 20 plus 50x, or you can put the 50 first, that doesn't matter, 50x plus 20. So how did I do it? I first found the slope using these 2 points. Then I used this formula. I chose this first point, but you could choose the second just as well. Plugged it in. Exercise 5 is the last one to do. If you want to try it, go ahead and see if you can figure out what the slope and the y-intercept is for each function. Are you ready? Here's how you do these. Let's go ahead and do these together. So what I would do here is I would break this up. I would separate that using distributive property 1/3 into both. So it would be 20 over 3 minus, because there's imaginary parentheses there. So I could say that the slope is the coefficient in front of the x, and the y-intercept is the constant. So again, the slope is the m, the y-intercept is the b. For part B, I would distribute that. So I had -2t minus 8, and then I would combine like terms. Doesn't matter if the variable's in the right or the left, always the number in front of the variable is the slope, and the y-intercept is always the constant. That would be the answer to exercise 5. And this concludes section 2.2.